Let us solve a question on exact differential equation. The question is solve the exact differential equation 4y plus 8t square del y plus 16yt minus 3 del t is equal to 0. We have to solve this exact differential equation. So in the earlier video I have explained what are the steps. So let's begin. First step is to check if it is an exact differential equation or not. For that, let me write it here. Let m is equal to, let us say this denotes the m, that is 4y plus 8t square, and this denotes our n is equal to 16y t minus 3. Okay, so to check whether it is exact differential equation, what we do, we take the derivative of m, that means partial derivative of m with respect to, okay, we take with respect to t. Okay, so here no t is involved in the first term. Derivative of t square is 2t, so 2 into 8 is 16t, so we get 16t. And symmetrically taking the partial derivative of n with respect to y this time, so derivative of y will be 1, so we are left with 16t again. Okay, you can see del m upon del t is equal to del n upon del y, because we got 16 as both the partial derivatives of m and n here. Okay, that means it is an exact differential equation, implies it is exact differential equation. Okay, now step second is what we do, we integrate this m partially with respect to y and treat t as constant. Okay, to get the function fyt. Okay, so we integrate this function partially with respect to y to get the function fyt. That means our fyt will be equal to the integral of this m, that is 4y plus 8 t square uh, del y. Okay, and we also add a constant term here, that means zt. This is being added because when this m function would have been differentiated with respect to y, the t terms would have, vanished. And when we integrate, we have to add an additive term that will, encompass all t terms here. So integrating this with respect to y, we will get here 4, integral of y is y square upon 2, so 2 and 4 gets cancelled, so we are left with here only 2y square, so 2y square plus integral of 8t square with respect to y, it will be equal to 8y t square, plus we have this additive terms for t. This was our second step. Let us say this is equation first and this is our fyt here. Let us say this is our equation second. Now what we do, we differentiate equation second with respect to t. Okay, that means we want to find out del f upon del t. Okay, so if we integrate this with respect to t, that means del f upon del t. So when we differentiate this with respect to t, here t is involved, so derivative of t square is 2t, so 2 into 8 is 16, so we get here 16 y t plus the derivative of zt will be z prime t. Okay, but what is this del f upon del t? Actually it is this term. Okay, this is our n also, so this denotes, this is del f upon del y, this is del f upon del t. Okay, simple thing. Now as I have told you, this del f upon del t is equal to n, and let me write it here, del f upon del t is our n, and we know n is equal to this 16yt minus 3, 16yt minus 3. What we do, we simply plug the value of del f upon del t, which is equal to n, okay, in this equation again, or we equate these two terms here. That means our 16yt, since del f upon del t is equal to this term, del f upon del t is this term, we equate these two terms, plus z prime t is equal to 16yt plus 3. Okay, here 16yt and 16yt will get cancelled, so we will be left with, okay, let me use another color here. So we are left with z prime t is equal to, it is minus t here, okay, so let me write it here, minus 3, sorry, so minus 3. After that, what we do, we integrate this z prime t with respect to t to find t term, okay, so we integrate this with respect to t, this term. That means our zt will be equal to the integral of z prime t dt, which gives us, so z prime t is equal to minus 3, I can write here minus 3 t dt, which comes out to be minus uh, sorry, we have only dt here, so integral of minus 3 will be minus 3 t, okay. Now what we do, so this is our z t here, we substitute this value of zt in this second equation to get the value of zt. That means our f y t will be equal to 2y square plus 8y t square, we have minus 3t plus the constant of integration, okay, so we can write here also the constant of integration, okay. So that means this is the solution of the given exact differential equation, okay. I hope I make myself clear in this video. So let me show something here again to make it clear. Since our 4y plus 8t square del y plus 16yt minus 3 dt is equal to 0, and I have told you this denotes our n, this is our n, this denotes our m rather, and this denotes our n, okay. Actually this also means our, if this is a function of let me write it here, if it is in this fashion, that means the partial derivative of f del f, that means this denotes then fyt denotes fyt is actually equal to, this denotes del f upon del t, and we have, sorry, del f upon del y times dy plus this denotes del f upon del t times dt, okay. So this is our m and this denotes our n also, okay. So it was here, how did I get this del f upon del t is equal to n, because this denotes our del f upon del t. I hope I make myself clear in this video. Thank you.